Hi, mathletes. Today we're going to create tables, graphs, and equations. So Dave, Tom, and Steve decided to purchase candy bars. Dave paid $1 for each candy bar. Tom paid $1.50 for each candy bar. And Steve paid $3 for a membership card, but he only had to pay 50 cents for each candy bar. Let's start by making a table to see how much money each boy spent on 0 to 10 candy bars. So we have the number of candy bars, and then we have Dave, Tom, and Steve. So we have 0 to 10. And for Dave, since he spent $1 on each candy bar, his is pretty easy to figure out. Plus one candy bar is $1, two candy bars is $2, etc., all the way to 10. For Tom, he paid $1.50, so they are increments of 1.5. And for Steve, even if he doesn't buy any candy bars, he still has to pay $3 because he had the membership card. But then he only has to pay 50 cents for each candy bar. So his increases by 0.5 or 1/2, 50 cents for each candy bar after the 0. So now we can make a graph from our table. We're going to say the cost of the candy bars versus the number of candy bars. So the cost is my y, or dependent variable, and my independent variable is the number of candy bars. So for Dave, if he doesn't buy any candy bars, he doesn't spend any money. If he buys one candy bar, it's $1, etc. And you can see that they're lining up. $5 for 5 candy bars, 10 candy bars is $10. So his is the red. Tom's is a little steeper because he's paying a bit more. He's paying $1.50. And so those are the dots. So again, for 10 candy bars, it's going to cost him $15. And then there's Steve. Steve's is the one that is the least steep. And you can see here that it crosses the y-axis at 3. Because remember, he has to pay $3 for the membership card. So even if he doesn't buy any candy bars, he still has to pay $3. But over time, he spends less money if you look at the number of candy bars, because if he buys 10 candy bars, it only costs him $8. So here's the table and here's the graph. And let's look at who gets the best deal. Well, Dave is going to get the best deal for 5 candy bars or less, because you can see here at the 5, he's spending only $5. You can see this in the graph, but you can also see it in the table, where if it's 5 candy bars, he only pays $5, where Tom pays $7.50 and Steve pays $5.50. Tom, although, gets the better deal than Steve if it's less than 3 candy bars. So less than 3 candy bars, it's only going to cost Tom $3 for 2 candy bars, but it's going to cost Steve $4. Steve gets the best deal, though, between Tom or Dave for more than 7 candy bars. So you can see more than 7 candy bars, he's getting a better deal. He only has to pay $7 for 8 candy bars, where Dave is spending $8 and Tom is spending $12. And Steve and Tom both spend $4.50 on 3 candy bars. You can see that here in the table because both Tom and Steve are at $4.50. And again, that's for 3 candy bars. And here in the graph, you can see where both of the lines intersect. Steve and Dave both spend $6 on 6 candy bars. Again, in the table, you can see Dave is 6 and Steve is 6, and that's the number of candy bars. So 6 candy bars cost them both $6. And again, it's where the green and the red lines intersect. Now let's look again at our problem. We know that Dave spends $1 for each candy bar, Tom pays $1.50, Steve pays $3 for the membership card, but only 50 cents for each candy bar. We can write these now as equations. So if we write them as equations, let's define our variables, where x is the number of candy bars and y is the cost. So for Dave, the number of candy bars is x, and we know he spends $1 for each candy bar, so y equals x. Remember, we don't have to put a 1 in front of the x. That coefficient is understood as a 1. For Tom, he's paying $1.50 for each candy bar, so y equals 1.5x. You could put the 0 in if you want, but it's not necessary. And Steve, he's spending 50 cents per candy bar. Again, you could put the 0 in if you want, but he has to pay $3 for that membership card. So I just put a 3, but you could put 3.00. It's the same. Now we can use these equations to solve some problems. Let's say we want to figure out how much each person spent on 24 candy bars. Let's start with Dave. Dave is y equals x. And x is the number of candy bars, so we can replace the x with 24. So y equals 24. For Tom, it's y equals 1.5x. So again, we know that the number of candy bars is 24, and that stands for x. So we replace the x with 24, and I get 1.5 multiplied by 24, or 36. And for Steve's equation, y equals 0.5x plus 3, again, replace the x with 24, and half of 24 is 12, and the sum of 12 and 3 is 15. So Dave spent $24 on 24 candy bars, Tom spent $36, and Steve got the best deal. He only had to spend $15. Now, what if we know how much money they're spending, but we don't know how many candy bars they bought? Well, let's see how many candy bars each one could purchase with $30. Again, now 30 is the amount, which is our y. So I replace the y with 30, and Dave could buy 30 candy bars for $30. Tom is y equals 1.5x. Remember, it's 150 for each candy bar. We replace the y with 30, divide each side by 1.5, and Tom can only buy 20 candy bars. For Steve, again, replace the y with 30, subtract 3 from each side, 27 equals 0.5x, divide each side by 0.5, and Steve gets 54. So in this case, Dave bought 30 candy bars, Tom only bought 20 candy bars, but Steve bought the most with 54 candy bars. So now you know we can use tables, we can use graphs, and we can use equations for solving these problems. So 3 different ways to look at it. Again, the graph is going to give you the big picture, the equation will give you more of an exact, and the table will show you those increments. I hope this helps, and thank you for watching.